Good morning, everybody. So today we're going to be going through the second part of the study guide. This is just more prep for the test tomorrow. You're going to see a combination of questions from both parts 1 and parts 2. Part 2. um, you're going to see also that the test is going to be about similar length to one of the study guides. Be about 20 questions probably, and maybe a couple short answers that you will have to send me a picture of your work for. I'll talk more about all this stuff tomorrow. I'm going to make a separate video to give instructions for the test. But also remember that our live stream will be tomorrow as well. And the way it's going to work is I'm going to give you tomorrow and Friday to kind of work on this test and ask questions and stuff like that. So without further ado, I do want to get started on the study guide because this video will likely be longer. Don't be afraid to, don't feel bad about skipping around if I'm talking about something that you know very well. Okay? Because the video, I just did one for the 6th grade, and it took about 15 minutes, so just to go through each question. So I'm going to try my best here, but let's get started. So which point has the coordinates negative 3.5, negative 3? Let me see if I can pull up my tool here. There we go. All right, so we have negative 3.5, negative 3. So negative 3.5, remember this goes x and then y. It's always the order for an ordered pair. Okay, so our y is here, and our x, what do I do? I don't know what happened, so. Okay, so our x, so it goes x and then y in that order. So our x is along here, negative 3.5, that's going to be exactly halfway between negative 3 and negative 4, so it's going to be around here. And then we see it's going down to negative 3 along the y. Up negative 3 along the y is about right here. So you can just go ahead. Let's see. That means that it looks like point Q has to be the correct answer. Alright, so what quadrant is the point negative 5, negative 3 in? So there's two things you need to know to be successful for this question. First off, we have to remember what a quadrant is. Remember, we said this is quadrant 1, 2, 3, and 4. It's just something you got to memorize. Negative 5, negative 3, well, let's see, negative 5, look for that along your x, right, it goes x and then y, so negative 5, negative 3, so let's see, that's going to be about right here. So, get rid of these now. It's going to be negative 5, negative 3 is going to be here, and we see that's in quadrant 3. 1, 2, 3. There you go. Find the distance between the points 8, 4 and 8, negative 8. So this is one I know these type of questions gave some people a hard time. Just remember, you always want to look at the scale. You see here we're counting by ones, right? So that means that each block is 1. So that means we're going 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10, 11, 12. So the difference is 12. You can also see that if you found the difference between our y coordinates, right, they have the same x, so if you found the difference between the y's, then you do 4 minus negative 8, which is the same thing as 4 plus 8. Which is 12. And for these answers, whenever you're working with a distance, the answer always does need to be positive. So you could have crossed this one out right at the start. Which equation describes the table below? So we need to think about which one of these equations represents what's going on here in our table. So we see that one pair of socks costs $5, 2 pairs of socks cost $10, 3 pairs cost $15, 4 pairs cost $20. Well, in each case, it looks like that the price of the socks is 5 times however many pairs there are. And that makes sense, right? If you're paying $5 for one pair, well, 2 pairs is going to be twice the price of that, and so on. So what we're doing is we're multiplying whatever x is, so these numbers, and this will give us our y. So you look at each row one at a time. You see, okay, so we have our x here. Well, we're taking our x, we're multiplying this by 5 to get y. Or we take our x here when x is 2, multiplying 2 by 5 to get 10. So in each case here, we're taking whatever x is, and we're multiplying that by 5. So it has to be this last one here. And just remember, it says this is a proportional relationship. The equation for anything that's a proportional relationship, the equation is going to look like this. Y is equal to kx. Remember, to find k, you can divide your y's by your x to get k. So, but this is only for proportional relationships. Okay, so again, we have another table, and we want to find the equation that describes it. You can read all this, and it'll help you understand what they're trying to, to really get at. But in the end, we already know what we need to find. So there's a proportional relationship here. This tells us that we're going to have an equation that looks like this. So now we just need to find out what k is. We want to find k. So another way you can do these is you take whatever your y is and you divide by x. So the first row we have 16 divided by 8. That'll give you 2. If you do 22 divided by 11, that'll give you 2. You'll see for each row you pick, right, if you pick the next one, 26 divided by 13 would also be 2. So this means our k is 2. So our equation must be y is equal to 2x. We're multiplying whatever our x is by 2 to get y. How many times will Harold have to turn the crank to lift 60 feet? Now this is one you're probably going to actually want to read the question for. The picture and sound electronics store has hired Harold to work in the warehouse. He uses a pulley with a hand crank to lift heavy boxes. The graph shows the proportional relationship between the number of times Harold turns the crank to lift a box, we're calling that x, and then the height of the box that has been lifted in feet, and we're calling that y. So when Harold turns the crank, right, or when he lifts the pulley 60 feet, well, we have to look for 60 feet on our graph here. 60 feet, right? We have feet here. So 60 feet. And then we said we want to know how many times he turns the crank. Well, let's just take that over. Okay. So it hits the line here. That means that we have to go down here. And we'll get 600 times. So when Harold turns the crank 1,000 times, how many feet will he lift the box? So this one's, it's the same, situation, but it's a different question. Turns the crank 1,000 times, how many feet will he lift the box? Well, remember, our x is the times that Harold turns the crank, so we need to find that when that's 1,000. So when x is 1,000, we need to figure out what y is. So go all the way up till it hits the line, and then we're going over here to see what the y is. So the y is 100. Okay? And really, what we're doing when we do this is we're finding the y coordinate here. So the coordinate of this dot right here on the line would be 1,100. So if you plug in this coordinate into whatever the equation is, you would find out that that works. Right? In each case, it looks like Harold has to turn the crank. Let's see, if you divide this by 10, that's going to give us how many feet it rises. And that's what you're going to see for these. Right? If you cranks it 200 times, it's going to raise 20 feet. 200 divided by 20 is 10. And you see each time every time this goes up by 100, this is going up. Let me use a different color. It's going up by 10 here. And that's each time, right? That the angle of this line, the slope of this line, that's not changing. So, all right. Now, all right. So let's take a look at this question. When Betty and her friends are 70 miles from shore, how long in hours will they have been sailing? Okay, so Betty and her friends are set out to sea on their annual fishing trip. The graph shows the proportional relationship between the time in hours that Betty and her friends spend sailing. We're calling that x. And we're calling the distance from shore in miles, we're calling that y. So when we're 70 miles from shore, Betty and her friends are 70 miles from shore. Well, let's look for that here. The x-axis is hours, y is miles. So, and we know that our y is distance anyways, right? So let's see, when our y is 70, let's figure out how many hours they would have been sailing. So to do that, you go over here to the line. Now we need to see, okay, what's the x coordinate of this point here? And it looks like that'll be 7 hours. All right, this next question, if you were one of the first, I think it was just really one or two people, yeah, maybe a few more, but the first, 3, 4, 5 people that took this, you might have seen a little mistake on this question that I did fix. This one, I don't know if you're going to see something like this on the test. I guess you could because it's on the study guide, but we'll see. After every hour, how much further do Betty and her friends sail away from shore? So really what I'm asking here, I don't ask for it directly, but what I want to know is either the unit rate. I want to know, oh, that's cut off. I either want to know the unit rate of this graph, or the constant of proportionality, we said that was k, or the slope, which we call m. Yeah, any one of these is going to give you the same answer here. So really what we're trying to see is, okay, every hour, how much further is Betty getting from shore? Well, after 1 hour, this is going up by 10 miles. Right? It's going from 0 to 1 on the x, but it's going from 0 to 10 on the y. So this means after 1 hour, Betty and her friends moved 10 miles further away from shore. So the correct answer should be this one. So if you did this one early, just make sure that you do understand that. Let me. Oh, there we go. Okay, so let's look at the next one. Find the missing number in the table of values below. So this one I give you a lot of information here. You get to see a couple rows. You get to even see the equation. So what we're seeing is that whatever x is, we're multiplying that by 3 to get y. In this case here, we're trying to find the missing one. Well, we know we want to find y, our missing number here. It's going to be equal to 3 times, well, in this case 20. So this means that, well, y must be equal to 3 times 20. Y must be equal to 60. Okay. So the next one here, we haven't done too much like this, but it's a very similar type of question. And it's one that is actually going to tie into what we're doing next in the class. So in this case, we need to find x. We know that y is 48, but we don't know what x is. So we know in this case, our y is 48. This is equal to 6 times whatever x is. Okay, so what we're looking at here, this is called a one-step equation. Something will either, maybe it won't be next week, but I think the week after will do. So it's okay though, because we have enough information here where we don't need to actually know how to solve those directly yet. But really, what we're doing is we're trying to think, okay, well, what times 6 will give us 48? Well, 6 times 8 will give us 48. So that must be it. So this is equal to 6. Now, maybe you don't really, like, oh, well, I didn't know that. Well, I couldn't remember what times 8 gives me 48, or, if you just didn't like what I did there, well, something else you can see is, okay, we could, we multiplied by 6 here to get to 6, but you could also think about, okay, if we multiply by 6, we could divide our y by 6 to get x. Right? 6 divided by 6 would give us 1. So we can do the same thing here. 48 divided by 6 will give us, that shouldn't be a 6, that should be an 8. So hopefully you caught that. Let me use red here. Right, because 8 times 6 gives us 48. So let's move on. which of the functions below are linear. So straight lines are linear functions, linear graphs. They're always straight. This is okay too if they have these little gaps in it, as long as it's still a straight relationship like that. So the only one here that's not linear is A, so it should be B, C, and D. Which equation matches the graph below? So this one here, let's see. Looks like we're going to want to compare books to inches. Let's see, books are X, inches are Y. Let me write that. So our books are X, our inches are Y. This is how much shelf space these books are taking up. So it looks like one book here takes up 1 inch of shelf space. Well, 1 and 1 are the same number. So let's try this out again. What about if there are, okay, if we have 2 inches of shelf space, that means there's 2 books. So it looks like there's 1 inch per book, so however many inches are being taken up on the shelf space is the same as how many books there are. So that means that however many books there are is going to be how many inches of shelf space it's taken up. So that means that X is equal to Y. All right, let's continue. Do these both. Find the slope of the following equation. I give you 2 here. So first off, remember Y is equal to mx plus b. Okay, so m, the number in front of the x, is the slope. Kind of just like the constant of proportionality, just like that k. K is also would be the slope of the graph. B is our y-intercept, and this is something that for a proportional graph has been 0. This is the y-intercept. Yeah, it's getting cut off. Let me write it over here. Y-intercept. Okay. So for this first one here, the number in front of x is 3. So that means our slope m is 3. For the second one, there's just a negative in front of it. Well, a negative x, when you have a negative like this means that the slope is -1, because -1 times x is actually the same thing as -x. So this would be -1. Now, just a little, now, like, what are slope and y-intercept? Just a brief refresher. If you're looking at a graph, this would be your x, or that'd be your y, this would be your x. So your y-intercept is where the line's crossing through the y-axis. So this is your y-intercept right here. And then the slope is like how much this line is changing, just like that constant of proportionality. If you, I recommend watching the videos I released last week to kind of learn more about this. Watch those math antics ones. But in general, we're not going to do not too much with graphing, but just like what you've seen on the study guide. So, Alright, let's take a look at these ones. Alright, find the y-intercept of the following equation. Again, remember we said y is equal to mx plus b. And we said this was our y-intercept, right? Or b. So all you need to do is just read these off. Okay? Y-intercept is 2. Right? The slope is 54, but the y-intercept's 2. So that's your answer. Now down here, it's a little harder, I guess, but it's the same idea. Whatever this is your y-intercept. So you need to do 3 times negative 4. Now we know 3 times 4 would be a 12. But we're multiplying by one negative number, so that means that 3 times 4 will be a negative 12. So that's all you got to do for these. Okay, let's get into the last couple of questions. Match the equation with the correct graph. We have y is equal to 2x plus 2. Really, all you need to do to solve this, sorry if the graphs are a little small. Let's see if I can zoom in here. Okay, that should work. So there's a y-intercept here. That's kind of the clue for this one. There's a y-intercept, and the y-intercept is 2. That means even if we don't know what the slope looks like, we do know that our graph should go through the y-axis at 2. Even if you don't know what the rest of it looks like. We do know this for sure. So this is the point 0, 2. And our y, x, and this is also our b, our y-intercept. So this is from here. Okay. So that means that it needs to cross through the y-axis at 2. Well, if you look at A, this goes through the origin, so that can't be it. This looks like it's going through negative 2, so this can't be it. And then C is also going through negative 2, so this can't be it. Well, by process of elimination, or you can just look at the graph, you see that this is crossing through and has a y-intercept of 2. So your correct answer must be D. Okay, which equation could describe the table below? Okay, so starting on one of the trickier ones. So you're going to want to look at probably each of the choices for this. If I multiply my x times 4, do I get y? These would have to work. If the equation describes the table, it has to work for each row. So if we do times 4, 0 times 4, well, that should give me 0. So that can't be it. All right, 4 times 0 is 0. So that won't work. I think it's going to be the same thing here because I know 5 times 0 is still going to be 0. It's not going to be 1. So it can't be this one either. Now it could be one of these last two. So let's see. If we do 4 times 0 plus 1, it does give me 0 plus 1, which is 1. So this does work for the first row. And it looks like it's going to work for the second, or for the last one. Right, because we're doing the same thing. We're multiplying 5 by 0. That's 0. You add 1 to it. So we get 0 plus 1, 1. Now this is, so we're still kind of stuck between these two. So let's look at the next row. So when x is 1, y is 5. Okay, well, let's plug in a 1 here for x and see what we get. We get 4 times 1, that's 4, plus 1 is 5. So this works. We try 5 and 1. This would give us 5 plus 1, or 6. Now, that doesn't work, right? Because we wanted a 5. So this means that this can't be it. Our final answer must be 4x plus 1. Alright, let's take a look at this one. Same type of problem. Yep, so let's go through each one. Let's just try it out and see where we can get. So let's see, we have 3 for the first row here that we're looking at. When x is 0, y needs to be 3. So let's see if that works here. If we plug in a 0 for x, 3 times 0 is 0, which is not 3. So that doesn't work. Well, y is equal to 3. I guess that works. Y is 3 there, so that's not necessarily eliminated yet. X plus 3, let's try this out. If we have 0 for x that we plugged in, plus 3 gives us 3. So that works. We said that one worked. And if we try this one, plug in a 0 for x here, get 3 times 0 plus 3, which is really 0 plus 3, or 3. So that works as well. So far we didn't get to narrow it down too much. We only got rid of the first one. But the second row should do a little bit more. Now for the second row, I'll use a different color, do blue. So we have 1 and 4 here. So y is not equal to 3 anymore, so this won't work. So we can eliminate this from the second row. Now let's see, let's try it the next one. X plus 3, so let's do 1 plus 3, and that should give us 4. So that shows us this second row works for this equation. And then let's try this one. If we do 3 times 1 plus 4, it was 3 plus 4 or 7, which is not a 4. So the second row eliminates this one. That means we just had to go through 2 rows of the table to see that this equation could only be x plus 3. Alright, so last but not least, we have this question here. Here, okay. So which table could match the graph below? So remember, the table is giving us, tables give us a bunch of coordinates. So we need to see, are these coordinates on this graph? So let's look at this first row here. When x is 0, y is 0. So this means that 0, 0 should be on the graph if this works. Oh, it's not. Right, we have a point here at -1, or at 0, -1. but not at 0, 0. So table 1 we already got rid of. Now, again, let's see. Let's look here. Let's look at table 2. We have 0, -1 as a coordinate. So 0, -1. Let's see, that'd be 0, -1. So that's 0, -1. Our y-intercept is -1. So this worked for the first row. Let's look at table 3 here. 0, 1 should be on the graph. All right, this first row, 0, 1. Now, we said 0, -1 was, that was right here, but I don't see anything right here. This would be 0, 1. There's nothing there, so this table can't be it either. That means that you didn't even need to go through the whole table. That must be our correct answer. Okay, so that's all I have for you guys today. Bring questions about the study guide tomorrow to the live stream. And we'll go through it then. I'm not going to go through test questions or anything during it, but I will go through the study guide. And if you ask me a good question that happens to be on the test, well, you know, that's what you get. It's your reward for asking a good question. So, please just make sure you're taking your time working through this. Overall, the scores have been really good. Really on both study guides in the 7th grade. So keep up the good work, everybody. 7th grade, I know we've had some issues this year in the classroom as far as, all that behavior. But I gotta say, virtual learning, you guys have impressed me. Both classes have impressed me more than any of the other classes. So keep up the great work. You guys are really doing a good job. So that's all I have. Sorry for the long video, but hopefully it was worth it. Take care and goodbye.